This is section 3.4, part 2. We want to graph this inequality. The first thing we do is we pretend we have an equal sign. So x plus 4y is greater than or equal to negative 3. And I notice right here that I'm going to have a solid line because it has the equal to on it. Okay, so let's try plugging in zeros. Let's see what we get. If x equals 0, then that x goes away, and I have 4y. I said that wrong. That should be an equal sign right there. I apologize. So if I plug in a 0 here, that goes away. I have 4y is equal to negative 3. So divide both sides by 4. And you get y is equal to negative 3/4. So that's the point 0, negative 3/4. 0, negative 3/4 would be about there. Now do y equals 0. If my y equals 0, then I have 4 times 0 here, which makes that whole thing go away. And I'm left with x is equal to negative 3. So that would be the point negative 3, 0. Negative 3, 0 is here. So draw in your line, and it's supposed to be a solid line. So I'm going to draw this in. And now I know I'm going to end up shading one side or the other. So I need to pick a test point, and 0, 0 is available again. I love plugging in zeros. They're definitely the easiest. So if this is my test point, and I'm going to see if it's true or if it's false. Okay? So I come back to the inequality, and I'm testing 0, 0. So that would be 0 plus 4 times 0 is greater than or equal to negative 3. So that 0 plus 0 is greater than or equal to negative 3. 0 is greater than or equal to negative 3. 0 is always bigger than a negative number, so this is true. This was my test point, and I tested it and it was true, so that means the side it's on is true. So this whole side of this line must be true, this side must be false, and you shade the true side. Okay, now we're going to do some compound inequalities. You probably have done this at some point before, but chances are you've only ever worked them when you have an and in the middle. And we are also going to have an or problem. Okay? Now, if you remember from chapter 2, and is intersection, which means we only want the part that they have in common. Or will be union, which means everything that is part of either answer is part of our solution, because union takes everything. Intersection only wants the overlap. Okay, so what we're going to do is we're going to graph both of these on the same coordinate system. And then we are going to look to see where they overlap. Okay, so I'm going to start off with this one first because it's the easiest. It's going to be a solid line, and so is this one. This only has one variable, so it's either a vertical or horizontal line. And if you have trouble remembering which is which, this, x, and 3, this is going to be your x-intercept. So I have to cross the x-axis at 3, which is here. Now ask yourself whether this line, if it's got to be either vertical or horizontal, which one is this forced to be? There's only one horizontal line that would go through that point. But a vertical line always has to cross the x-axis, right? A horizontal line does not have to cross the x-axis. It could be up here and never cross. It could be up down here and never cross. So this variable, whatever it is, it tells you what axis you must cross, okay? So this is a vertical line, and it is a solid line. So I'm going to draw this in. Okay. Now I'm going to use a test point, and I'm going to figure out which side to shade, but I'm not going to shade it yet. And that's because I'm only interested in where they overlap. Okay. So let's figure this out. If I use a test point, 0, 0 is available for this. So let's test 0, 0 in this one. I plug in 0 for x, 0 for y. There's no y to plug in for, so don't worry about that. Is greater than or equal to 3. 0 is never greater than 3, so this is false for this line. This is the false side of this line, so that means I would be shading this side. What I'm going to do instead of shading it right now is I'm just going to draw a couple of arrows. It tells me which side I'm supposed to shade, but it's not on there and messing everything up. Okay, so I've done the thinking, I just haven't shaded yet. Okay, so now let's go to this one. I want to pretend that I have x minus y is equal to 2. Okay, I can use intercepts for this. If x is 0, that goes away. I have negative y equals 2, so y equals negative 2. This would be the point 0, negative 2, 0, negative 2. Now let's find the other one. If y equals 0, then that minus y goes away, and I'm left with x equals 2. So that would be the point 2, 0, which is right here. So draw in this solid line. Okay. And now we need to figure out which side of this line we're supposed to shade. Now sometimes, often I should say, your test point for the first line will also work for the second. But if my second line happened to go through there, I would just pick a different point. But we can still use the same test point. And it might be true and it might be false because we're talking about this test point in reference to a different line. So now take 0, 0 and plug it in up here. 0 minus 0 is greater than or equal to 2. And 0 is not greater than or equal to 2, correct? That's false. Okay, so if I test this side and it was false, that means I'm supposed to shade this side of this line. So I'm shading here and here. Okay, so now we just have to figure out which part is our answer. We want the section that's shaded by both of them. Okay, now it might help you to use a couple pieces of paper or an index card or something and shade and cover up the part that you don't need. Okay, so if I look at this, I know I'm supposed to shade this side of this line, which would be this part. And then I'm supposed to shade this side of this line, which would be this part. So the part that's double shaded is right here. Just that one little region, okay? If this were union instead of intersection, this area would be part of your solution and this area would be part of your solution. That is the main reason we do not just graph and shade both of them at the same time and look for where it's double shaded. And that's because your answer will look exactly the same as if it were an OR problem. So the arrows here will help you out a whole lot. Remember the index card trick, it can help you too. Okay, so let's try this one. It's very similar. Right here we had X, here we have Y. So just like that one was a vertical line, this is a horizontal line that passes through 2, which is right here. Your y-intercept is 2 right here. This one is solid. This one is going to be dotted. And when you have a mixture of the two, that's when people tend to get into a lot of trouble. We just get in the habit of just drawing our lines. This is a solid horizontal line through 2. So draw that in. Okay. 0, 0 is available as a test point. And if I plug in 0 here, 0 for y, 0 is greater than 2, which is false. This side must be entirely false, so this is the true side. I would be shading above this line. Okay, now let's worry about this one. We pretend that we have 6x minus 4y is equal to 10. Okay, let's try using intercepts. If x is 0, Then that's 6 times 0, which makes that go away. I have negative 4y is equal to 10. Divide both sides by negative 4. And we get that y is equal to, that's the same as negative 5 halves, which is probably, if you were asked to find the intercept, this is how you would give it to me. But to graph it, just do 5 divided by 2, and you'll see that it's negative 2.5. So 0, negative 2.5 would be right here. Okay, now let's find the other one. If y equals 0, well, if y equals 0, that's 4 times 0, so that's gone. So I have 6x equal to 10. Divide both sides by a 6. And you'd get that x is equal to, that reduces to 5/3. So if you were asked to tell me the x-intercept, it would be 5/3, 0. Now 5/3, 5 divided by 3 is approximately 1.7. So go to 1.7 and 0, which is right there. Now this is supposed to be a dotted line, so make sure we type it in that, or draw it in that way. Okay. Now 0, 0 is available for this one as well. So take 0, 0 and plug it into your inequality. 6 times 0 minus 4 times 0 is less than 10, which gives me 0 minus 0 is less than 10, and that's going to be true. So for this line, the dotted line that we're talking about right now, our test point is on the true side, so we would shade this side. Okay, use the index card trick if it helps you. On this line, I'm shading this side, so I'm going to cover up this side that I'm not shading. For the horizontal line, I should be shading above it, so I would cover up this part that I'm not shading. And so my answer is right up here.